Hello, everyone, and welcome to our Tuesday, August 13th, 2024 CARC Workforce Development Interest Groups call. This is the Staff and Student Workforce Development Interest Groups. Today, we're led by the Staff Workforce Development Group that is co-chaired by myself and Tim Middlecoop. You can visit our site to learn more about our interest group. This interest group is for you and by you. So we're here to talk about things that are interesting to all of us that we want to learn. We are bound by the CARC Code of Conduct, so definitely check that out. We're looking here to support RCD professionals, support people who are interested in becoming RCD professionals, and provide support for institutional RCD programs. RCD, if you're not familiar, is Research Computing and Data. And our interest groups tend to work together. We share this monthly call, and we work on practices for onboarding staff, training, student program development for student employees working within our RCD organizations. And today, we'll be talking about learning pathways. We have a presentation by Julie Mullen. She joins us from MIT Lincoln Laboratory, and she'll be talking about how to identify learning pathways that can help us guide career development for RCD professionals and more. And I'll hand it over to you, Julie.
Great. It says identifying pathways. One of the things we're going to talk about identifying, but we're not going to really have a lot of solutions. We're still at the early stages of this. And so we want to talk about what we've learned about building HPC pathways. Much of this is some of it's HPC centric, but a lot of it, of course, is research, computing, and data centric because that's what HPC is used for. So the outline of the talk is to go through a motivation. We gave a survey, so the survey design, the data analysis, and then the results. And we're going to go from a high level and go down to the researcher category, to one of the professional roles. Then we're going to look at what we've learned from that, of what the learning challenges are. We're going to look at some current activities in this area for moving these forward. And then I have sort of a learning pathway pilot proposal just to motivate discussion. So the motivation, the HPC community, and when I say HPC, you can of course just substitute research, computing, and data community. It's growing and expanding in every direction. Right? The demand for the skills is greater. Everybody's using these systems now for their research, and the range of domains and backgrounds for people coming in is broad and diverse. And so when you try to figure out what the required skills are in order for you to build a career or learn new skills to do your research, so finding the right content and doing it in an efficient way isn't always easy and obvious. One of the ways that businesses get around this issue of how do you know what it is that you want to learn and how do you build your career and build the skills that you need is by creating learning pathways. Now, some of these are fairly obvious if you're like a doctor, or my stepdaughter is a veterinarian, lawyers, teachers. There's an organization that sort of sets out, this is what you need to learn, and these are the courses that you'll take, and you take them at professional meetings and professional conferences, or you take them over the summer. Teachers, I'm thinking, take them over the summer and get professional development credits. And if you think back to academia, when you were a student, the traditional academic approach is that someone else has set out what the requirements are. So those requirements become, I have to learn that. And then universities and faculty set out, they create a curriculum, which is effectively a learning path. And then the faculty advisors guide the student through that set of courses so they fulfill the requirements, they develop the skills for whatever role they want as they graduate and go on to develop their career. Once you become a professional and you're not in one of these professional societies that sort of dictates what your development path is, now we're sort of, which is what most of us are, we're building our own paths. We all have our own goals. We're like, I want to head in that direction, or I want to develop this set of skills. But how do we determine if I want to take a career step, what those skills are? What skills do I need? How do I learn them? is there an order that makes it easier to learn them so that I'm scaffolding my learning, and what level of understanding or skill is required? And those are difficult questions, and it's part of what we hope we could help provide some guidance on. So in order to get a sense of where we are right now, we did a community survey at Supercomputing 23 as a BOF session. So, and the idea was basically, can we get a baseline of where we're at, what people think about what needs to be done as part of developing pathways, whether or not they feel they're able to do them. Maybe we're misunderstanding. And so we had a survey which used Google Forms. We had open questions on a Likert scale, 1 to 5, multiple choice questions. And the data was collected during this pathfinding in HPC education and training BOF session. So a key piece to that is to understand that this is a self-selected audience. First of all, there are people who were at Supercomputing. Secondly, there are people who are interested in pathways or HPC education and training. And we have to keep that in mind, that this is not a full understanding of our audience. It is a subset. Okay, so thinking about the survey design for a minute, we wanted the demographics. You know, what is your highest degree? What's your academic background? And what's your current professional role? We had a sense that there's a mismatch there. We were just curious. This is one way of finding out. And then we wanted to understand where people were in terms of how important they thought their HPC skills were. So there is something called the High Performance Computing Certification Forum, and they got together. This was a community effort. It was a fairly substantial community effort to build a skill tree. Many of these skills will apply to research computing and data. I don't know if you've built your own skill tree that is specific to what you're doing, but the skill tree is out there. You could easily see it. Many of them overlap. And so the primary level skills, each one of these primary skills in the bullets of performance engineering, software engineering, et cetera, has many, many sub skills. But we looked at the primary skills and we asked people, you know, how important those were for them, and if they could list the top 5 skills that they use in their current role, just to get again a feel for where we are at this point. And then we wanted them to evaluate the importance of the skills from those categories for their job, their current job. Furthermore, we wanted to know you can't, when you start to train people, especially adults, because they are problem driven, they have a goal. They want to learn something. I want to be able to do this thing. I want to be able to fix this. I want to be able to troubleshoot that. So what is your goal? Where are you headed? That then helps you figure out, or sort of scope out what it is that you need. You don't need all of it, right? You need some of it. So I think about hiking. Nobody starts hiking the Appalachian Trail with everything they're going to use over the full course of the trail. They start, and along the way, people send them new boots. They get rid of the old ones. They send them food, and that's where you want to be scaffolding people. What do you need now? And your next journey, your next leg of your journey will be a different learning journey. So then we wanted to understand the relationship between these high performance computing, the primary skills, and what your learning objectives are. And so the importance and how difficult it is to find material. And then finally, you know, what is your approach to developing these skills? Do you know how to build your own path? Do you know where to find the materials? Do you know what you need to do? Because if people did, then maybe we had misunderstood something. So for the data analysis, the numerical data was aggregated via Google form. Whew, easy. Scores, so we have a number of scores that were averaged across the whole data set, and that was pretty much part of the Google form process. But then, in terms of professional categories, we had roles. People described their roles, and so we roughly bin them into categories. Within those categories, then we sort of had to look at the data as a more manual process. This category, here's the data. This is an average it. And then we had open responses, and of course, that's a manual data analysis and exploration process. So now we know what the survey was, how we went about analyzing the data. Let's look at the results. The slides will be available. I know I'm going through it quickly, and I know also that these slides and these graphs are hard to see unless you have the slides in front of you. So They are available. So here's something that we had sort of thought was happening, but we didn't. This sort of confirms it, and that is that when you look at this slide on the graph, the pie graph that is on the left, there's a large purple block that is bio and life sciences. There's a large green block that's engineering, and then there's a large dark blue, well, 12% dark blue, and that's physics. When you look at the right, all of a sudden there's this big yellow orange, and that's computer science. And so people were in a number of different domains, and now they think of their current professional role as computer science. Now, it may be computational science, computational engineering, computational biology, but in their minds, it's computer science. So there is a mismatch between the training that you have, your educational preparation and your professional role, which makes the idea of a learning journey, your own learning journey, even more important, because you may have places that you have to fill some gaps. And then we looked at the target skills in aggregate, and the desired skill sets vary widely. So taking a look at this plot, the next thought was, okay, we need to dig into this. So we need to go by current professional role. So we aggregated what we had and what people had said their roles were, and we had roughly 6 educators, 7 system administrators, 2 facilitators, 13 researchers, 5 technologists, and 7 students. So we went through and we looked at these groups. Again, this is where it's really important that you actually have if you want to see it, that you actually have the slides. And so we're sharing them later. This is the individual's perception of how important the skill is for their current role, and to fulfill developing that skill in order to fulfill their learning objectives. So if we look at the left, the plot on the left, that first set of bars is performance engineering. I don't know if, oh, can you see my mouse? I don't know if you can, but the dark blue is educate. Oh, excellent. So just to give you a sense of who is what, the dark blue is educators, the orange is students, the gray is system administrators, the yellow is facilitators, the blue is researchers, and the green is technologists, and that goes across all the way. So again, we have the importance of skill, or the perception of the importance of that skill, varies across varies from role to role. Next, when we look at the learning objectives, again, we see that these are varying. You have people, I just want to learn, I want to learn some personal technical skills. I want to develop my own personal technical skills. Some people, really, their goal is to better understand workforce development and to be mentoring other people in their development of skills. Some people have very general roles. A lot of these goals are, I want to be able to scale up a problem. I want to be able to scale up this type of problem in this domain. And then others are, I want to learn how to run this code on that system. So it's broad variance there. Some people want just enough to complete their research. If you're facilitating researchers, you've seen all of these already. I want to scale to a larger system, or here's one that's much broader. I want to transition from being an HPC user to a developer. That's very different than I want to know just enough to complete my research. So it's a big range of learning objectives. And then if you know what skills are important, you know what your learning objective is, can you find the materials to put that together and create and build your path for yourself with the materials? And this is the perception of difficulty with regard to actually developing and actually finding the material. And it ranges sort of all over the place. Facilitators found that software development, they didn't feel that it was hard to find, because the higher the number, the higher the level of difficulty. And so whether it's because it wasn't as necessary, or they knew exactly where to find it, or whether software development is different from programming, we don't know. These are, again, this is a sort of the first base step of getting a feel for the way the community is thinking about this. But overall, people seem to think that finding the materials, the materials that they need is difficult. So that's now the big picture of the whole group. The next level down, which is like we dug down a little bit and we looked at the subgroups. Now we're going to go down one more level. We're actually going to look at the individual responses for the researcher category, because we're seeing wide variance across the whole set. We're seeing wide variance now when you break them out into their categories, their roles. So what do we see next? Okay, so in looking at the individual responses, right, so we had 40 respondents and they divided into roughly 6 categories. The researcher category was the largest, and I think for us, it's the group of people that we see the most. So we were interested in understanding what they felt they needed, how difficult they felt things were to find, how difficult it was to build their pathways, and how they were approaching the problem. So this was 13 respondents. There are 3 computational researchers. There should be an R in there. There's a researcher from material science, an astrophysicist, a computational meteorologist, and a social science researcher. So it's a fairly broad range of researchers, and should give us some sense of what across that. It's a broad enough range that we should get some valuable feedback. So again, how important are the skills? And looking at the chart, it's kind of all over the place again. There's still significant differences in the perception of the skill importance. So at this point, we were thinking maybe it's not clear enough what those skills, what the definition of those skills are, which is entirely possible. Maybe they in fact don't. Maybe their level of understanding right now is such that they don't appreciate how important things like performance tuning might be, in order, especially if you're at a system where you're going to get charged for the use of that system. If you're working in a system that's maybe local to your campus and you're not being charged for it, then maybe that doesn't matter. That doesn't come into play. So there's some other information that we don't know, and so at this point we're taking away that there are still significant enough differences in the perception of skill importance. I think the biggest likelihood here for this difference is not really understanding what those skill categories are. So again, a diversity of learning objectives, just as we'd seen before. These are a little less diverse. Most, if you even though it's written, and so it looks at first glance as if they're very different, if you actually read them and think about them, for the most part, these are, I want to scale my problem onto a bigger machine. My problem doesn't fit on the small machine. I need to speed it up, or I need more memory. And AI, someone wants to use AI to improve the scaling of their machine. Well, AI alone is going to need a larger machine, so you'll need to learn about scaling. So these are slightly less diverse than some of the differences we're seeing elsewhere. Okay, so now we're back to learning objectives, skills. Do you know what your learning objectives is? Do you know the skills that you need to get there? Can you find the material? And this again, this is slightly less broad, but it's still quite broad. That's really what we want you to take away from this slide. Okay, so what does all this mean? All of these results, from the top down, we're finding that there's a broad range of perception about how important different skill sets are. There's a broad range of learning objectives, and the ability to find the material, sort of that sense that it's easy or hard, is also fairly broad. So what does this mean? Well, it brings us to what these learning challenges are, that, actually being able to find the material and go through it and recognize whether it's good reference material or good learning material. And those two things are different. And when you go and you're searching on Google, Google's going to bring something back to you. It's not going to know whether or not it's learning material or reference documentation. So, so you have to actually manually go through all that. So if we could make it that easier, I think people would find that helpful. There's no training that's tailored to their needs. Yep, or the time investment. And I would say about the time investment, more and more we're seeing, certainly in the, I'm also part of the Open edX educators working group. So I've done a lot of online learning now for well over a decade. And in that environment, people are putting things like, this should take you this much time. So you know how much time it's going to take. Everything's modularized so that you can do it at your own pace when you have time. And the same is true when you think about if you get any newspapers online or if you read things online, there's generally a rough, this should take X amount of time. This is a 4-minute read, a 6-minute read, and then there's longer articles that take longer. And it's something we should think about adding into our own training resources. I think it would be very helpful for people. And then, so again, the professional learning is task oriented, and even if you can find everything, it's not clear how to consume. This was written as or put things together. So the idea there is scaffolding. How do you scaffold? That's what educators think of. And if pathways can be scaffolded, and that makes it not only easier to learn the material, but it stays with you because you have some grounding, and it's not just sitting there floating in the air. So let's see. So, how can we make learning easier? We were talking about this a little bit before. You were talking about making a centralized list of resources. That's one way. Making and more efficient ways of identifying desired content. So that's essentially tagging. This is something that the HPC education group is doing for high performance computing education. Again, a lot of it is going to overlap with research computing and data, just because that's a lot of what we do. More support for that's an organizational item. So, but clear instructions on how to develop intermediate and advanced skills. This is something that once you're out of school, it's a little bit harder to develop those. And that's where, the difference between the expert and the novice, being able to put a pathway together for someone so that they can go through that, it would be very helpful, because otherwise you're not quite sure where to find those. There's less intermediate and advanced material out there, so it's a little bit harder to find. More specific examples, self-guided resources, and to better understand what skills are required or useful for different jobs. We will come back to the thoughts on this slide in just a minute. So all of these pieces that are important for making learning easier, different groups and different organizations are working on them, and my thought is always, how can the community work together in a way that they can enhance one another, even though they may have bits and pieces that don't overlap, right? Those places where you overlap, how can we work together to make a better experience for everyone? Okay, so the recommendations are, we need an easier navigatable training system, and materials should be easy to find. It should be accessible, interoperable, reusable. It should provide learners with methods to identify the skills they need to reach their goals. And it should, and maybe even templates so when people are making it, if there's a template guides for skill progression, that could be helpful. And you could, provide more relatable examples. And so all of this in the community can be summed up as a learning pathway or learning journey, and that's the route. If there's a template guide of how to progress through, that's the learning pathway. If there's a place where you have this set, here's where you're starting, you want to go there, here's the set of skills that you need, that's the learning pathway. And that then shifts from the traditional, that allows the individual to shift from, I was in university and I had a guide as an advisor, to now I'm a professional and I'm building my own career, and I'm building my own learning pathways, learning journeys. However, there are some real challenges here. We aren't going to it's not practical right now for us to have personalized learning pathways. right? At some point, wouldn't that be wonderful? With AI and large language models, we might get there. It's not going to happen for HPC and probably not for RCD, either HPC or RCD for a while, because they're busy doing that with other people. So the money is elsewhere. But essentially, it would be highly personalized pathways just are too narrowly focused to be able to help the entire community, and we don't have the resources to do that many of those. So what can we do? Well, here are some of the current activities. Here are all, this is the high performance computing high performance computing certification forum skill set, right? This is the tree. So in the middle, you have the actual name of the skills, of the major skills. So HPC knowledge, big data analytics, performance engineering, software development, which probably overlaps with a lot of the stuff that you're doing. And then the use of HPC environments. Some of this would overlap if you are using a cluster. It doesn't have to be the big supercomputers. This is still relevant. And so, you look at the next level, the sort of the darker ones here are software design, software quality, agile methods, and then you go into smaller skills. How do you do logging? How do you do debugging? How do you portability, exception handling? I mean, these are all skills that certainly research software engineers are working to understand. And then working through automating. So if you look at the use of HPC environment, automating common tasks, workflows, these are the sort of skills. So giving people this and asking them to build their pathway, either for where they want to go or how they got to where they are. And we've done this now at ISC in 2023, and we've done it at ISC in 2024, PERC in 2024. And we hope to be able to get the data from this, although when you have arrows and circles, it's a graph, but getting it in a format that we can actually get some interesting output from will be a challenge. But that is one of the things that we're currently working on, is developing these pathways. The next is some work that's being done in the UK. And so Veronica and Jeremy are both from the UK. And we wanted to highlight these because they may be things that are relevant, very relevant to research computing. They are very relevant to research computing and data and workforce development, but they may be less well known here in the United States. And so this is for building technical professionals. So there's the Universe HPC, which is understanding and nurturing an integrated vision for HPC in RSE, research software engineering, and HPC, which would overlap with research computing and data. I think it's just not a term that's used in the UK as much as here. So what's the basic idea? Identify the competencies and skills. Design different curriculum. I mean, a learning pathway is a curriculum. It's just personalized a little bit. So define different curriculums, learning pathways, delivery mechanisms, ways of getting that material to people. And then as you do that, when you do that, you will find that there are gaps in terms of learning modules that don't exist yet. So then you make those as well. And finally, building a community, facilitating professional networking and peer support. So that that's the whole goal then that sums up the key elements of Universe HPC. And then the other program is called Step Up, a strategic technical platform for university technical professionals. And I'm going to go right to the next slide here because these are the four relevant pieces. And that is that you develop new technical communities of practice, and you build more diverse communities of practice within these fields. And then as part of that, you're going to develop training programs, upskilling, and ways of bringing new members into the community so that into software data infrastructure, and training them so that they can come into this community of practice as peers. So that includes having career pathways. And so career pathways, learning pathways, they go together, and mentoring, and then finally they're setting up the policy. And that's well, it's something that'd be great to have here too at the national level, but I think in some cases, sometimes I think we're too big. Like when I watch some of the stuff that the UK is doing, I think you're able to do it because they're slightly, again, scale. It's what HPC people do. Scale is the challenge. Okay, finally, I want to propose, just to get the discussion going, I want to propose this idea of a learning pathway design pilot. So at the laboratory, we think in terms of systems. So when you think in terms of system, you have something that's working together, a number of components working together as a system. Currently, the community has a number of efforts that are going on in this area of training, workforce development, being able to make training materials more available, coursework that's more available and more usable, so findable, accessible, interoperable, and reusable. That FAIR idea is a big piece of what's going on right now. And so just to bring out three of them, actually, I also should have added in here, so there are four. There's the HPC certification form. We've already seen their skill tree. There's the data that we have from our boss. There's your job families. And I needed to add, and I realize now that I didn't, this HPC Ed program that's trying to build all this content that we can use that fits FAIR. And so is there a way that we could integrate these efforts to develop a few example pathways? I mean, it seems to me that the CARC job families provide the career pathway, and then you've got that career pathway is going to have an associated learning pathway. So is there a way that we could design just a few example pathways? And part of this as a pilot, part of the goals would simply be building a working group or an interest group, a group of people who want to work together on this issue, and then capturing the challenges, trying to bring all of that together and those different groups together, and the interest of what they have, RCD, RSE, HPC, there's definitely overlap, but there are also areas where they're different. And so capture the challenges that are associated, with merging those groups and the information, and from that develop some best practices. I mean, I think that those would be goals that would move us forward a little bit, and then we'd reassess. Okay, well, great. What do we have? What can we do next? And so based on that, the other discussion question is what other potential community efforts could we have? And before I come back to this, I want to thank you for your attention and ask if there are any questions. I'll go back here.
Thank you very much, Julie, for that presentation. I think now's a great opportunity for questions and discussion from anyone who has thoughts.
I'm seeing, questions. It's not just questions. If you've got suggestions, those are also things that would be really useful. Like where to go. I deliberately didn't put next steps because I wanted to do that with, as I'm hoping that we can get something here where we have enough discussion that next steps will sort of filter up out of that, right? Out of that discussion. Things that you folks are doing. Shall I stop sharing? Would that make it easier for?
Yeah, sure.
Okay.
I guess I'll give a comment. This has sort of been my long-term goal for a long time to get something like this. So you've kind of put it into words what I've been thinking about, and I've been kind of working on private, and this is sort of the direction that I've been taking the interest group over the last couple of years. Is the journey to get to that point. And so right now where we're at is developing the resources to go through this learning path, right? So you really well articulated what the learning paths are supposed to be and what they're meant to do. And what I'm looking at with the work from the Nexus Day that we had at PERC just now is that have a list of the catalog of resources. We can identify different characteristics of them to place them, like you had that graph there, and then in a future future point, start continuing the work of developing these pathworks. But first, getting an idea of what the resources are, how to characterize them, potentially develop the gaps, and then go from there. And so the earlier work was characterizing where people are in their career and things like that. So it works. This meshes well with the sort of the high level thing that I've been working with. This interest group is in that direction. In general, we're a little bit more pragmatic here in the interest group, which is we do discussions about what people are interested in general in workforce development and trying to do what's relevant. But that's sort of my high level objective, was to get to something like this at some point in the future.
I think we're trying to get there, and some of the pieces already exist. Some of the training, the group of people, we're all doing training, HPC education and training, and the high performance computing, the HPC certification form has done this sort of inventory of skills. Now, I will admit there are skills on there I'm like, I would like to see this other thing, and this skill here, or this skill group over here really isn't that relevant to me. So I've felt that as well. And it's interesting because I remember seeing somebody else talking about building courses with that idea in mind, physics courses with this idea of like, what is the skill, not so much what is the skill, but the knowledge, well, is it a combination of knowledge and skill inventory? Like, what do you need to know in order for me to feel that confident in saying that you learned the material? And that somehow listing that inventory makes it a little bit more concrete for students, even at the undergraduate level, so that they, and I've seen that, I've taught courses where they're used to theory, and it was a graduate course, and I said, okay, let's stop and think for a minute. Okay, this is what you've learned in terms of theory, but this is a set of skills, and the skills are the things you put on your resume. But you've learned these, you've gained these skills over the course of learning how to do this other thing, or how to use it in practice.
Yeah, and I think another a point along those lines is the assessment part of it. So how do you assess folks in terms of assessing what skills do you have, right? Is it at what depth and things like that? And that also takes a lot of effort to develop those types of things as well. But I think that could be useful for an individual that's maybe new into research computing and data and has an idea where they want to go, but they may not realize that they picked up some skills in different areas. So doing an assessment in terms of both their interests and their technical abilities, I think, would help along in those paths as well. So
yeah, go ahead.
I think one thing that's a little bit different than from both of our perspectives is that here we're looking in this group at more general, so more RCD as a broader scope, not focused more on the sysadmin. So bringing in not sysadmins, but traditional HPC systems, but bringing in a little bit more broader perspective in terms of facilitation, things that may not actually be classical HPC jobs and things like that as well. So just sort of broaden it up a little bit. I think that's where there might be a little bit of difference, but that also makes it more difficult to assess the landscape and makes it a lot bigger.
So that two comments to that. One, I agree with you. I don't do much system administration. That's the piece that I'm there going, well, I don't really need to know that part. But the other piece is, I mean, certainly there's the use of an HPC system and parallel computing. Now that's it. It just is that as we go forward with research, everyone's going to need to know that. We're just not going to get away from it anymore. So understanding it at some level is crucial. And for a while, people were like, "Oh, I'm just doing AI, or I'm just doing this other thing." It's like, yeah, but you're getting there's a point at which if your research gets large enough, you have to move on to some other system. So to understand the basics of those becomes important. I agree on the research facilitation, because that is in fact what I've done, and what I've done for, I feel like I'm the only person I know that has done it for as long as I've done it, because I've done it for over 20 years now. And everybody else I know keeps moving up to become like some other higher level position. But but I have research on the side that we do. So my balanced mind that way. But I think that there are, the big data analytics was not built out here, but I think if you start building that out and build it out more into data analytics, you would see a little bit more overlap. So I completely agree with you on that front. I will say that the HPC certification forum looked into how would you do this assessment. That is a really hard challenge. What the goal was to be able to say, this person passed this, and this, and now when I go to hire them, I can feel confident they do it, in fact, have that skill set. So I would recommend at some point sitting down with the folks from the certification forum and chatting with them about some of the lessons they've learned. And maybe they should actually write out a paper about that or do a presentation, because there are some challenges that they've worked on, and it would be interesting to know how best to address things like that. And I'm thinking now in high school, do they still do this? Do they still do aptitude tests? Like, what are you interested in? Because that would be one way of helping with this whole like career direction.
And that's what
Good
kind of what I meant
fits.
by assessment, not more the certification route. There's the SIFTED grant that Henry Neiman's doing around actually doing certification for folks that are in the RCD field as well. So other comments and questions from the audience. We don't need this to be the Tim and Julie show. So
Well, Julie, I'll comment. You said something about the definitions of the skills being possibly confusing. I will say I did in the BOF the part of drawing the pathways, so not the same exercise you're reporting on, but I think that is a question because it's not always super clear. Not everyone has the same view of what that skill means. So I could see that being a concern. And I was thinking about, you're trying to figure out what pathways people have. And as you point out, we all come from many different backgrounds, many different academic fields, different training. So there's not, in any case, one sort of standard. But I wonder if looking at who's in the field now versus who might be in the field in the future, that maybe the pathway looks fairly different. That right now it's mostly people who sort of stumbled into research computing in some way or another. Maybe there are high schoolers out there who say, I want to be a research computing professional, and that's awesome if so, but I don't think that's a very common answer as to how you got into this. But maybe in the future there will be. And that pathway may look different from someone who first became a physical scientist, a biologist, an engineer, and discovered an interest in this.
So I agree. I mean, when I think about where I started and who, what the background was. I mean, so one of the big drivers for me is that traditionally you went to graduate school in a STEM discipline, or really just in an engineering or physics discipline, and there was one steep path up that hill to particularly for using HPC. Research computing and data wasn't the thing at that point, right? So even there, you've gone from I'm doing HPC on big systems to research computing and data more locally, as well as more paths. You can't just have just one path, because then there's a gatekeeping. So a lot of this effort is to try to open it up and provide more paths so that people know where you come in. Excuse me. So so if you have a sense of like, this is my skill set, now what else might I need? I think that could still work. And yes, they'd have to be adjusted as people go. That's why I think the guided sort of templates for where things fit, like, this is a path to building deeper skills of such and such. And systems change, right? Now we have lots of people doing AI, large language models. We have cloud. We didn't have that when we started. So all of that is new and has to be accounted for. I wonder if you would have people doing the idea that people would be like, I want to be a research computing data professional. Man, that would mean that our outreach efforts would have been really productive. So, and which I'd love. That would be great. If I had high school students saying, that's what I want to do, that'd be awesome. We need but and so yes, we need to be, it needs to be flexible enough. So this is like yet another challenge, right? Because it needs to be flexible enough. I'm going to put the HPC certification, there we go, in the chat for anybody who's interested in it. That was what I was looking up. But do you have any, so what are you're building, your interest in terms of workforce development and training in particular, what is the approach that you're currently using? Anybody? I'm looking for input from the audience.
So given the time, I think it's a good place to pause, but definitely that's a great question, Julie. For all of this to think about, maybe if you have a thought, you can post it in the chat or in the meeting notes. But I want to say again, thank you, Julie, for joining us today. Next month's call, the Staff and Student Workforce Development Interest Groups will be looking at some of the outcomes from RC Nexus Day. So if you were at RC Nexus Day and you participated in the people track, looking at the resources that we were trying to list and categorize, that will be a great chance to follow up. If you were not at RC Nexus Day and you're interested in getting involved, it's a great chance to do so. You haven't missed much yet. So definitely hope to see many of you back September for continuing that discussion, trying to build that list of resources that someone could then maybe in the future fit into their learning pathway. And thank you all for joining today.
Thank you for having me. Thank you for listening.